have a port that is connecting to your edge device, like your computer, then definitely that is where you are going to deploy an edge. That is where you're going to configure an edge port. So then what does it say? We go to switch 3, Giga 10 to 24 over 3 are connected only to terminals and need to be configured as edge ports. And if I go to my 3, my switch 3, and under my switch 3, I remember yesterday, I think it's Adam who was asking how we select a range of ports on a switch. And you can see the command is there for you. You simply have an interface, but I don't know if this particular switch that I've selected will enable that. VLAN. I don't have the range for this particular version of this, but if at all it agreed, then you can select a number of them. So there is 10 up to 23. Given that Giga, this one does not support, then I have to do it manually, which is a lot, but allow me to do that. 10 or to this 24 STP edge STP edge port enable. You can see it's going to be quite a lot of work. I have to do one by one, but I have not, because it seems not to accept the range command. Then I will go to 11 again and set it again to the edge port type. I would go again to 12. I set it to edge. I go to 13 and set it to edge port again. I go to 14 and I will set it to edge port again. I go to 15 and set it to edge port again. I will go to 16 and set it to edge port again. Go to 17, but if it was agreeing, you see the range command can really help in this, but this version of the switch seems not to be agreeing to that. There is 18, then we have that. They're supposed to do all the way up to 24. It's quite a number, but allow me to do it. 19, there we are. Make it an edge port. And then again we have our 19 there. Make it an edge port. Then we have our 20. Let's again make it an edge port. Then we have our 21. Let's make it again an edge port. If only they are connecting to any devices. Let's go to 22. Let's make it an edge port. Again, we have our 23. Let's make it edge device. Again, we have Again, we have our 23. 23. Let's make it an edge port. Then we have our 24. Let's make it an edge port. We say they go directly from disable to forwarding. They don't need to participate in the calculation of the topology of your network. They are not. It's not necessary. So there you are. So what follows is a verification follows is verification. Mark the root bridge and the role of each port in the lab environment based on the actual network convergence. So then disable any port on any switch and check whether the traffic can reach all other switches through the backup links. And you have your reference there, what you need to have in switch 1, switch 2, switch 3, and this is just confirmation on what you have, and then you have your quiz at the very end there. Let me request for reactions from you people. Request for reactions from you. A request for reactions from you. Adam. A request for a reaction from you people. Question, comment. Question, comment. Question, comment. So that is that session for the session for the STP. But what I can say is that the most important thing is you need to understand about the root bridge and the non-root, how the primary roots and the secondary, how you elect the root bridge. That is very important. Then the roles of the ports, be it the alternate, be it the designated, be it the root, be it the backup, be it the edge. You need to understand their roles. Then you need to understand the steps. That is what we mean by the disabled, the discarding, listening, learning, and forwarding. Very important for you to understand that, and how you elect your root bridge. That is very, very important for you to understand. If no question, then let's go to the next one. Next lab session is about Ethernet link aggregation. One is about Ethernet link aggregation. When we have allow me to save this before I go to the aggregation bit. I'll need to save this before I go to the aggregation bit. This is quit, and I quit again. Let me save this. Say yes. That is S3. We go to S4. Let's also save this. Yes. Let me go again to S2. Also save this. Let me go to S1. Let me also save this. Let me go to the overall project. Here we are. Let's save it under a different name. It says save as. And, I will save it as. We'll save it as. Lab. See the screen. can say as lab 3, 2. I can simply call it 2. See, this is we call it lab 2, lab 232. Let me save it. There we are. There we are. There we are. Then again, we call this. We save. Just want to be sure when I close, I will get what I have saved. So the next part we have is the link aggregation, and link aggregations are mainly for purposes of improving bandwidth, that is capacity, because it's like if I have 2 ports, 2 Ethernet ports, each having a bandwidth of 1G, and I aggregate 2 of them, then I'm operating at 2G. That is simply what mainly, in a very simple terms, that is what aggregation is all about. And again, there is also an aspect of reliability when you aggregate, because you can configure it in such a way that, when the 2 links, when I combine the 2 links, if one fails physically, the other one can still continue. The other one can still continue operating. So the end user will not be affected, will still be able to communicate. So that is very important. So especially for the backbones, where availability and bandwidth are very important, then that is the most appropriate place for you to do. That is the most appropriate place for you to do aggregation. That is the most appropriate place for you to do. So next, I have that. You have the explanation there. It is to improve bandwidth, improve availability, and also you can do what we call load balance traffic. You can subdivide traffic to the ports that have been put in that, in that ETH track. So you have your objectives there. There's the first lab there. You have 2 switches and you want to aggregate. Remember that when you are doing aggregation, the number of interfaces on either side, let's say the actor and the other switch, or switch 1 and 2, must be the same. You cannot put 3 interfaces on switch 1 and form another channel with switch 2 and select 2 interfaces on the other side. It will not work. And of course, they have to be of the same. If it is Ethernet, it has to be Ethernet, and the numbers must correspond. You have your first assignment there. Lab topology for configuring the links. And the first thing is, let me start a new topology. There. Do you want to save? Yes. And this one, there we are. I have my switches there. Let me use the 57